Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we were discussing about analysis of time series, index numbers, statistical quality control. Since the course Applied Statistics is being studied with the economic aspect of statistic, we were also studying the demographic data. In the just previous session, we were doing the discussion about vital statistics, wherein we studied the measurement of fertility. In continuation with the topic about vital statistics, in this session we are going to talk about the measurement of mortality and life tables. In continuation about the measurement of fertility, one example will be done, that is compute net reproduction rate from the data given below. That is age group of child bearing females and their survival rate are given. Age group of the females who were capable of giving birth to child 15 to 19 and their survival rate is 0.969. Similarly, the age group of females is 20 to 24 and their survival rate is 96.7%. So, like that 0.967, like that the survival rate is being given and we are asked to compute net reproduction rate. First, the age is given here, 15 to 19 age in years, and the fertility rate per woman is 0.016, survival rate is given, and then female offspring of survivors is F into S, that is fertility rate into survival rate is the female offspring of survivors. This particular value 0.015504 is obtained by calculating multiplying 0.016 with 0.969. So, 0.015504, next 0.137 into 0.967 gives you 0.132479. And then totality of this last column is the summation of F into S is equal to 0.418281. Okay. So, net reproduction rate according to the formula is 5 into, because the 5 represents the number of years in the age group. Okay. So, 15 to 19 represents age group of 5 years. Therefore, 5 into summation F into S. So, F is the fertility rate into survival rate, totality is 0.418281. So, 5 into this 0.418281 is 2.0191405. So, net reproduction rate is 2.091405. After discussing about measurement of fertility and doing some illustrations in measurement of fertility, next we shall step into discuss about measurement of mortality. Like fertility, many rates are used for measuring mortality. Just to recall, in measurement of fertility, we used the rates as CB or crude birth rate and specific fertility rate, gross fertility rate and total fertility rate. Also, the reproduction rates were discussed along with gross reproduction rate and net reproduction rate. So, we shall discuss here the measurement of mortality rates one by one. crude death rate first of all, like crude birth rate, here crude death rate CDR. This is the simplest measure of mortality and is being defined as CDR is equal to D divided by P into 1000. Just to recall, in crude birth rate we multiplied B birth rate into P. Okay. So, CDR is equal to crude death rate per 1000 of population. That is D is equal to number of deaths from all causes which occurred in the population of a given region during a given period, and P is total population of the given region during the given period. The CDR is relatively easy to compute, requiring only the total population size and the total number of deaths. Also, it is a probability rate in the true sense of the term, as it represents the chance of dying for a person belonging to the given population may be supposed to be exposed to the risk of dying of something or the other. That is, a CDR measures the decrease in the population due to death. However, like crude birth rate, crude death rate also has some drawbacks. We shall see that one by one. Actually, it ignores the sex and age distribution of the population, same as in CBR, and the probability of dying is not the same for the young and the old, and for males and females. An old population probability of dying is not same. We cannot expect the same kind of death with male as well as same kind of death with female, and the same kind of death with young and the old. So, an old population can exhibit a relatively high CDR, because as people grow old, their chance of dying is more. So, the old population relatively high CDR is present. Also, the probability of dying may be different for different races, occupations and regions. However, the CDR may well be used for comparing the mortality situations of the same place at different times, provided the periods compared are not too far apart, because in a stable large community, the age sex composition of the population changes very slowly. So, the main drawback is the age and sex distribution of the population is not considered. After studying CDR, crude death rate, we will study specific death rate, that is the same as in measurement of fertility. A crude birth rate was studied and then specific fertility rate was studied. So, here specific death rate is going to be studied. The CDR does not include specifications as to age or sex. Where such specification is made, it is known as SDR. So, also sometimes we are interested in the mortality conditions of a particular segment of the community. Example, infants, childbearing women and old persons. So, an SDR is a death rate computed for a specified segment of community. The formula for computing SDR is given by SDR is equal to number of deaths which occurred in a specified section of the population during a given period in a given area, divided by mid-year population of the given age group in the given period in the given area into 1000. So, the SDRs are the true and best measures of mortality, as they provide an idea of the chance of dying in each of the age groups selected for computation. Nevertheless, for general purposes, death rate specific for age and sex is one of the most widely used types of death rate. So, it also applies as one of the essential components required for constructing life table and net reproduction rates. This particular topic, life table, is going to be studied further in the next topics. The specificity by age and sex eliminates the differences in death rates arising from variations in population composition. In respect of these characters, and to this extent, such rates can be compared from one geographical area to another, because the climatic and calamities happens to a particular geographical area. So, that also has to be considered when we talk about deaths. So, of course, they can be compared from one period to another period for the same area, because during a rainy season the death of people is more compared to summer, isn't it? So, however, it does not eliminate other characters such as race, white, non-white people, occupation, locality of dwelling, urban, rural, etc. Now, we shall do an example in computing CDR and SDR from the following data. Age group is given as 5 to 15 and 15 to 65, and population 5 to 15 represents the child age group and 15 to 65 represents the adult age group, and the population in a particular area and then above 65 represents the old age people, right. So, 5 to 15 aged people are 9,000 and their death are 18, because this will be actually low because the age group is from 5 to 15 and they are children, right. And 15 to 65 the population is 11,000 in a particular area and the death is 55 numbers, and above 65 the population is 3,000 and the death is more because of old age and 210. So, just take the totality, and this is the question. The total is also given. The total population in the particular area is 28,000 and the death is 403. The solution is given by, we have to calculate CDR, age groups under 5 and population, deaths per 1000 is being calculated. That is for the age group of under 5 the population given in the question is 5,000 and death is 120, and death per 1000 is calculated as 24, that is death divided by population, that is deaths per 1000. This is for population, right. For 5,000 it is calculated, so death per 1000 will be calculated as 120 divided by 5,000. Okay, this is per 1000, so into 1000 gets calculated and gets cancelled, and 120 by 5 is 24. Similarly, 18 by 9,000 is the rate, and for 1000 it is to be multiplied with 1000. So, 18 by 9 is 2, like that the values are calculated. And next CDR, crude death rate, is equal to total deaths, which is 403, and total population is 28,000 into 1000. So, 403 by 28,000 into 1000, this is equal to 14.4 per 1000. Hence, we have calculated CDR for this problem. Next, we shall calculate the SDR, standardized death rate. Sometimes it is not possible to compare the crude death rates in two localities as the actual age distribution in one locality may differ materially from that in another locality. If for instance there are two communities, in one of which the adult population is larger and in the other the lower the older people are greater in number, that is the older people are lesser in that particular another community. So, it is obvious that lower mortality in the first community may be due mainly due to its different age composition. So, the CDRs fail to reveal the real mortality. For the purpose of comparison, the rates are brought on some standard basis, that is the standard population for this purpose may be taken as the population of the country as a whole, or some other population may be taken as the standard, that is some standardization has to be done with respect to population. This involves adjustment of crude death rate to allow for the known differences in the age composition of the population involved. There are two main methods of age adjustment. One is direct method, another one is indirect method. In direct method, in the case of crude rate, the weighting is done by the population of the area to which they relate. The standardization is done by weighting each and every population. But under this method of adjusting for age, the specific rates are weighted by the population distribution of another area chosen as a standard. Also in the direct method, the rates specific for one region are multiplied age group by the corresponding populations of another region considered as standard population to obtain an age adjusted rate. Thus, the standard population to the actual age distribution of the given population is done. In indirect method, For the purpose of computing standardized death rates by the direct methods, it is necessary to know the number of person and SDRs. SDR is a specific death rate for all segments of the given population. Sometimes we have a population classified according to age, but the SDRs for the individual age groups may not be known. Instead, we might have the total number of deaths and hence the CDR may be known. Also, where a large number of district rates of mortality require standardization on the basis of national population, the direct method would entail a very large amount of computation. Okay. We shall see the problem wherein we calculate the CDR and standardized death rate for the two populations A and B from the following data. Compute the crude and standardized death rate of the two populations A and B from the following data. Age group years has been given under 10. Population in area A is 20,000 and the death in the town A is 600. Likewise, in the area B, the population is 12,000 and for the age group under 10, and the 372 persons under the age group of 10 have died in the area B. So, this kind of information is given. Similarly, 10 to 20, 12,000 is the population in area A, 240 is the number of deaths in area A, 30,000 is the population in area B, and 660 is the number of deaths in area B. Now, you have to take the total of each population A and the total of deaths of A and population of B and death of B. CDR is calculated as death divided by P into 100. So, the solution goes like CDR is D divided by P population into 100 for town A. For town A, the total deaths is 3640 divided by population is 122. This is D and this is P. Okay, so similarly, this is P and this is D. Okay, so 3640 divided by 122000 into 1000 is equal to 29.8, and for town B is this 3349 divided by 122000 into 1000 is 27.4. Now, for finding standardized death rate, the population has to be standardized. Taking population of town A as standard population, we just calculate the population for A is taken as it is because standardization is done with respect to A. So, A's value will be taken into account as it is. So, A 20,000, 12,000, 50,000, 30,000, and this is same, and death is also same 600, 240 like that, and death rate per 1000 is calculated. Death rate per 1000 is calculated as 600 divided by 20,000 into 1000. 0 gets cancelled, so it is 30. Similarly, this 20 is arrived as 240 divided by 12,000 into 1000. Okay. Now, for town B, we have to standardize the values with respect to A. Population of B is 12,000 and death is 372, and the death rate per 1000 is again 372 divided by 12,000 into 1000. Okay, so likewise these are calculated. SDR for town A and SDR for town B is separately calculated. First, let us write the SDR for town A. That is, the standardization has to be done as I told you already. 20,000 into 30 plus 12,000 into 20 plus 50,000 into 25 plus 30,000 into 35 plus 10,000 into 50. Now, the standardization is done by dividing it with 20,000 plus 12,000 plus 50,000 plus 30,000 plus 10,000, and this value comes to be equal to 29.9. Okay. Similarly, SDR for town B is calculated with respect to the death rates for per thousand for town B. So, 20,000 into 31 plus 12,000 into 22 plus 50,000 into 26 plus 30,000 into 35 plus 10,000 into 60 divided by the total of the population. Total of the population is 1,22,000. So, 34,000 divided by 1,22,000 is equal to 31.4. We can now say that the death rate in town B, because this is 31.4 whereas here it is 29.9. The death rate in town B is higher than in town A. The next illustration is with respect to finding the standardized death rate with respect to employment. That is, you are given the following statistics of population and unemployment in your country as a whole for a standardized age distribution. The local administrative area in which you live has been given. Calculate the standardized unemployment rate in the country as a whole and standardized rate of unemployment in the local area and the crude rate of unemployment in the local area. That is, like death rate, unemployment, like birth and death, employment and unemployment is taken into consideration here. In the question we are given the age in years and the standard population is given, age constitution, unemployment rate is 5%. Okay. So, the age group is 15 to 30, 30 to 45, 45 to 60, 60 and this is the total. A standardized population for age constitution is 250, 350, 350 people, like that, 300, 100 and this total of the population, standard population is 1000 and unemployment rate is 5. A 5% of 250 are unemployed in the age group of 15 to 30. Okay. And local population is for the age group of 15 to 30 is 300 and in the age group of 30 to 45 the local population is 300 and unemployment rate is 4%, 9% etc. respectively. The solution goes like calculation of standardized and crude unemployment rate. So, for the age group 15 to 20 standard population, number of persons is 250 and unemployment rate is 5 and the local population is 300 and unemployment rate is 4. So, the whole tabular column is written in this format for making the calculation easier. The same question only, but it is written in this format. So, number of persons in standard population is 1000 means in the number of persons in the local population also should be 1000. Now, the standardized unemployment rate SUR for the whole country is just multiply 250 into 5 plus 350 into 8 plus 300 into 12 plus 100 into 20 divided by total of the population, that is 1000. 9150 divided by 1000 is equal to 9.15%. Now, standardized unemployment rate with respect to local population. With respect to local population, you just see 250 into unemployment rate is 4. So, 250 into 4 plus 350 into 9 plus 300 into 12 plus 100 into 20 divided by 350 plus 350 plus 300 plus 100. So, 9750 divided by 1000 is 9.75% and crude unemployment rate is just with respect to local population. So, 300 into 4 plus 300 into 9 plus 350 into 12 plus 50 into 20. So, 9100 divided by 1000 is 9.1%. Now, after discussing about fertility rates and death rates, we shall discuss about a life table. Another way of summarizing a mortality experience is by means of the life table. Actually, the life table shows on the basis of current mortality rates the number out of 1000 births who survived to certain specified ages and numbers dying between these successive points of age. The life table gives this information for each integral age from 0 to an upper limit beyond which it is convenient to regard the number of survivors as negligible. For instance, an investigator studying the mortality prevailing in a community during a given period asks if 1 lakh babies born at the same time experience throughout their lifetime the given mortality, how many would reach age 1 and how many would reach age 10, 20, 30, etc. Further, when the life of all these 1 lakh children would run its course, what would be average longevity per person? A life table supplies answers to such questions. Actually, the life table presents in a more vivid way than the death rate, the mortality experience of a community during a given period by asking such questions. How to construct a life table? The construction of a life table can be best explained with this example. Now, observe 1 lakh infants all born on the same day and dying as they pass through each year of life at the same rate as was experienced at each of these ages by the population of Delhi in 1976-78. In what graduation would that population disappear? How many would be still left alive at age 1, 5, 26, etc.? How many would die between age 15 to 25? What is the chance of surviving from age 45 to 50? What would be the average length of life enjoyed by the 1 lakh people? And such information can be obtained from different columns of a life table. For the sake of illustration, we give below a part of life table from the census of India. So, age X, living at age X is denoted as IX, and dying between x and x plus 1 is denoted as dx, and mortality rate is denoted as qx, survival rate is denoted as px, living between ages x and x plus 1 is denoted as Lx, and living above age x is denoted as Tx, and mean after lifetime of at age x is denoted as e power 0 x. Okay. This is a census report taken from the census of India. The age group is from 0, that is infant children is 1 lakh, dying between x and x plus 1 is 7186. So, mortality rate is 7186 divided by 1 lakh is 0.0171886, and then survival rate like the usual calculations we do it 0.92814, and living between ages x and x plus 1, there are so many persons out of 1,96,407 has been living, and after the age of x also people living are found to be 5874000, and mean after lifetime at age x is 58.74. So, this information was extracted from the census of India. Now, column 1 gives the years of age, column 2 gives number of persons who attain exactly age x. Thus, the number 1 lakh against 0 year age indicates the number that began their life together and are running the first year of their life. Similarly, 92814 against 1 year age indicates the number who have completed first year of their age and are running the second, and so on. And the column 3 gives number of persons among the LX persons, IX persons reaching age x who die before reaching x plus 1. So, death rate is equal to Ix minus Ix plus 1. In the above table corresponding to x is equal to 0, we have dx is equal to 7196, that is total number of persons and total number of persons living, okay, per 92814. Survival rate is 92814. So, therefore, which is equal to 7196, because 1 lakh minus 9284, 1 lakh is the total number of persons and at x is equal to 0, and 92814 is the survival rate per the 1 lakh, therefore, 92814, just subtract, you get the death rate. When x is equal to 1, similarly, we found 92814 minus 91394. Okay. So, like that it is considered, and it happens to be 1420. Likewise, each column is found out. Now, after studying the life table, what are the uses of life table? To present a clear picture of mortality prevailing in a given population group, and to help in the analysis of effects of mortality on the age and sex composition of a population, which is considered to be a drawback for CDR, and to help in the measurement of population growth in the computation of NRR in particular and in population projection. So, that is in estimating what the size of the population will be at some future date. Also, to help in actuarial business and the government, it is employed by life insurance companies in determining the rates of premium for policies of persons of different ages. The government may use it for the determination of rates of retirement benefits for the employees. To help in making an estimate for the accuracy of census enumeration and vital registration data. It may be, however, noted that accuracy of live table depends on the accuracy of the registration of death and of the enumerator of the population of census. In this session, we discussed about the measurement of mortality rates, that is crude death rate and specific death rate. Also, standardized death rate, the standardization is done with respect to the population, and standardized unemployment rate also were studied with an illustration. Based on the discussion in this session, following questions may be posed: brief about CDR, SDR and standardized death rate. What are the drawbacks of CDR, crude death rate, and specific death rate, and how it is overcome? This example is to work out to find out CDR and standardized death rate. So, calculate the crude death and standardized death rate of the total population and compare them with the crude death rate of the standard population. What inference do you draw from the comparison? That is, after finding the standardized death rate, we will be able to say whether it is higher standardized death rate or lower standardized death rate. So, age group is given and standard population is given, population death is given, local population and population death in local population is given. Thank you.